This video is going to be on getting empirical formulas from percent composition or even just mass values. So remember, when we get the empirical formula, that's the most reduced form. Okay? It might also be the molecular formula, the actual formula, but it's always the most reduced ratio of the elements. So let's think about for a minute what these ratios mean. So for water, this is the empirical and the molecular formula for water. Remember, this 2 means there's 2 atoms of hydrogen for every 1 atom of oxygen. Or we could say that if we had a mole of these, there would be 2 moles of hydrogen for every 1 mole of oxygen. What the formula does not mean, remember, is that there's 2 grams of hydrogen for every 1 gram of oxygen. Remember, really there would be, for every 2 grams of hydrogen, there would be 16 grams of oxygen. 2 moles is 2 grams for that. Hydrogen is 16 grams, oxygen is 16 grams per mole. So remember that the ratio is not in terms of mass, it's in terms of moles or number of atoms. So the easiest way to do these is going to be to get them in moles and figure out what the ratios are from there. So this is, by the way, this is question number 5 in your notes. I'm going to do A and B right now. So the first problem says you have some red copper oxide. And it tells you that the mass of the red copper oxide is this. They react it with some hydrogen, and it produces that much copper. Well, if the whole compound was 1.256, and that much copper was made, that means we had 0.14 grams of oxygen. So we're trying to get the formula of this copper oxide. We obviously know it's Cu. We're just trying to figure out what number goes there and what number goes there. Is it a 1-to-1 ratio? Is it 2-to-1? What is it? So we need to change these into moles. We can't just get the ratio in grams. Remember, change these into moles. So we have 1.116 grams of copper. These are ones I would not round on. So 63.5 grams of copper is a mole. We do that. That's 0.0175 moles. The 0.14 grams of oxygen. 16 grams is a mole of oxygen, and that is 0.00875 moles of oxygen. Again, that's not a whole number ratio, so I can't put in this with the copper and this with the oxygen. So to get the ratio, see if, is this number double that? Is it triple it? Is it a 4-to-3 ratio? Just divide by the smaller one. So this is the smaller one, so I'm going to divide this by 0.00875 and divide this by 0.00875. That comes out to be about 2, comes out to be 1. So your formula then is Cu2O. There's twice as many coppers as there are oxygens, 2-to-1 ratio in terms of moles. The second problem there, be letter B, says you have a compound that's 66% calcium, 34% phosphorus. You guys could probably get the formula of that since you know how to write formulas, but let's say we don't know what the formula is. So now we have percents, but remember, we can pretend like we have a 10-gram sample of the compound or a 100-gram sample of the compound or whatever you want to pretend like you have. All we need to know is what the ratio is. So if we said, we have 100 grams of calcium phosphide, we're trying to figure out what numbers go there. If we have 100 grams of that compound, that means we'd have 66 grams of calcium and 34 grams of phosphorus. Again, we need to turn this into moles, turn that into moles. So divide by the more masses. I'm just going to tell you what that is. 66 divided by 40 is 1.65 moles of calcium, and 34 divided by 31 is 1.097 moles of phosphorus. Now, to get the ratio, that's going to be kind of a tough ratio. Divide them by the smaller one. So I'm going to divide both these by 1.097, divide by 1.097. When I do that, I get about 1.5 and 1. Well, I obviously can't write Ca 1.5. Phosphorus 1. So you have to kind of know that a 1.5 to 1 ratio, if I double that and double that, that becomes 3, that becomes 2. So it's a 3 to 2 ratio. So it's Ca3 P2. I will do the next problem on a separate video.